meetings. In the old days, when we still had to have physical meetings, we battled to get people come, and most probably only the Gauteng people used to come, because we used to do it in the Roodepoort Milders Drift area, and now we get good attendance from all over the country. So it's actually a very nice system to handle. But let me just introduce the agenda. The first thing is that if you feel there's any competitive discussions that could break the law, then please say so, because we will be recording this meeting. And then, of course, if it's irritating you, you can leave. So that's why we're recording it. But it's very important to understand the whole Competition Commission thing. And we as ASPASA are very strong on that. And we've never been fined, where most of the other associations in this part of the industry have all been in trouble. Because, I don't want to talk about it, but, some people have businesses that work together. So we stay clear from competition stuff, and on the agenda, the rules are there. And then just quickly, most of you, I can see it, most of you are used to Microsoft Teams. I think it's very simple. If you're not talking, take your picture off, and your voice, shut it down. And if you want to talk, put your finger up. There is a place to put it up. And I think it's a very easy, understandable system if you've done it a few times. So I'm very fortunate in this field. I'm not an engineer, but I've got most probably one of the nicest, best qualified engineers in the country that chairs my technical committee for me. And Theodolan, he started this thing and he's pushing it. And we've actually, from this, we've moved over to young professionals, and we've also got people that are talking about EXA and so forth. So, Theodolan, thanks again for basically drawing up the agenda or giving us the speakers, and then secondly for your willingness to handle this meeting. So welcome everybody. I'm going to Donald Duck now, and I'm not going to show my face. I'll be in the meeting, but I won't be playing any more role here. Thanks, Theodolan.
Thanks, everyone. Maybe I can just show my face for a second as well. I see we've got quite a few new faces in the group, so welcome. I think there's an entourage of Lafarge employees here. But yeah, you all are welcome, and it's important. I think the benefit of this group is to ensure that we communicate with each other and try to solve problems. So I think just from a background, from an engineering perspective, we start to get busy now to December time, planning our big projects, etc., while everyone's on leave. So it's the ideal opportunity to finalize our last 2021 engineering meeting for the year. So just to recap from our last meeting that we had a presentation on SAP plant maintenance, and then on the aggregate process optimization. We did 2 supplier presentations from crushing experts and OEMs, sorry. And then I did a presentation on engineer development in the industry. So today's agenda is also exciting. We have a data integrity improvement by Alan Goldsmith of Sable. I see Teresa quietly came in a few minutes ago, so she will take us through an Excel overview. Then we have a student paper from Matthews Masagela. Matthews, I saw you we're excitingly online there, so you'll have your slot soon. And then we've got a supplier presentation from Alex Root of Interflon. So without further ado, I think just one thing at the end, we always have a space for engineering issues or concerns. Please take up the platform and don't feel shy. You can use the tab at the side, etc. Bring up some issues that we have in the industry. I, for one, will bring up 1 or 2, but it's important that we share and discuss. That is why this platform is here. So without further ado, I'll put on Alan Goldsmith, if you can come on. Thank you.
Great, Alan. Thank you very much. I'll just put my camera on briefly. Can everybody hear me all right?
Yes, you can, Alan.
Great, perfect. Well, good morning, ladies and gentlemen, and thanks very much for the opportunity to speak to you. I'm very briefly, my background, I'm an exploration geologist, having worked in base metals and precious metals throughout Africa for the last 30 years now. I have my colleague, Meshach Biela, who's on the meeting. He's the product owner for the product called Sable. And that is a product falling under the DataMine umbrella. So DataMine is the company and Sable is a database solution, data management solution. And that's what I'd like to talk to you about. Not heavily on the product, but slightly at a higher level in terms of data integrity. So without further ado, I'm just going to turn off my camera and share my screen, and we'll get going. If anybody can't see my screen, then obviously it's best to shout. And I'll just ask Meshach to keep an eye on the meeting for me. And if anybody wants to raise their hand and interrupt with questions, please go ahead and do so. So I'm just going to start with a couple of sort of important aspects, really. Obviously, you know, my background means I'm not highly familiar with your sector of the industry. However, I do believe there's a lot of common aspects. And one of which obviously is many of you.
Sorry, Alan.
Yes.
Matthew has his hand up. Matthews.
Sorry, I'm just going to drag my Teams dialogue to the side so I can also see. Yes, Matthews.
I can't see your screen, sir.
Okay, can the others see my screen?
Yes, yes, we can see it.
Yes, we can.
Okay, then Matthews, I'm not quite sure what you may need to do on your side.
May I suggest that Matthews log out and log in back and see if that works?
Thank you, Annika. So Matthews, if you can do that and then just let me know if you can see.
So I should do what? Sorry, come again.
Just to leave the meeting and then just to join the meeting again.
Oh, okay.
Alan, I think for the sake of time, if you can continue, it is recorded as well, so you will be able to pick it up.
No problem. Thanks, Dylan. Okay. So obviously many of you are in the business of exploiting a commodity of some sort, whether it be sand or aggregate or clay for bricks or limestone for cement, etc., etc. And obviously a very important aspect is to know, well, how much of that do you have? And obviously the quality. And then secondly, you will then be selling a product of some sort. It may just be a raw product, or it may have gone through some processing of some degree. And therefore, you need to keep track of the quality of that product. Very often there will be penalties, for example, if you don't provide according to a certain spec, for example. And basically, the foundation behind those two issues is the quality of your data. And that's really what I want to address this morning. Now, Sable has been an industry leading solution since 1983, and it's actually an acronym. And originally, the definition was a standardized approach to borehole logging for exploration. And its objective was to provide a solution whereby you can basically configure and implement a data standard for all of your what we call geoscience data. So it may be from original exploration holes, for example, through to blast holes in a pit, production sampling. It may be sampling from stockpiles, sampling from conveyor belts, sampling from trucks before they leave your mine site, for example. Many aspects of geoscience data would come into your operation. And that, you know, that acronym, when it came in, was a long time ago, and the solution was developed originally in the Witwatersrand gold exploration. However, it can be applied across any sector, we believe, of the sort of minerals industry, and of which the sand, aggregate, etc., is a large component, a huge component worldwide. And over the history of Sable, there are sort of three major problem areas which have repeatedly come up with many of our clients. So if we just look at the three, and I'm just going to go one row at a time, going from left to right. So a common problem is what we often refer to as once-off or disposable project databases. And this often occurs often in a spreadsheet environment, Excel. It might go to Microsoft Access, for example, but very often operations are just running and managing their data through spreadsheets. And in addition, it's also very often reliant on a person, sometimes just one person. And if something happens to that person, your sort of data asset, as we see it as an extremely valuable asset, can disappear very quickly. And some of the solutions that we look to address is obviously bringing accountability. When you're working with spreadsheets, you often result in many copies of what end up being not the same data because somebody manipulates them. So we need a solution to basically bring integrity to that data. Through the long history of Sable, we obviously build on best practices through a whole variety of different clients working in different jurisdictions, and also to remove sort of ad hoc hacking of the data. Very often people see things and it might not, oh, I don't really like that. In an Excel or a spreadsheet environment, it's so easy to change things. And, many of your companies may be listed, obviously many of you aren't, but I'm sure many of you will be aware that there are very strict rules and regulations now with listed companies through SAMREC, etc. And companies who are working not just in South Africa, overseas in Australia or the Americas, are then have to be compliant with their codes, their mineral reporting codes. And basically, so our objective with Sable is to implement a standard. So you're not tying your data to one person or a group of people, and you're also not allowing different people to implement different standards on the same operation, for example, which can also occur. I mean, a simple example might be logging holes or logging pits for sampling. And you've got two different people and they log it differently. One person will say this is light green, the other person's going to say it's dark green. And a recent meeting we had with somebody in the clay brick sector, emphasized the importance of color in that particular sector. And you want to implement a standard there so that you've got consistent products, basically, that you're exploiting and selling. And I'll come to a couple of examples of the features in Sable which help to address that. In this case, it's SPD stands for a Sable project definition, and how we actually create a database. And we'll come to that shortly. A second problem is when we have loose or often absent data management protocols. So it's all very well bringing in a very good consultant, for example, to do your sampling or manage your drilling program, but you might have a standard in place and then they decide to do it according to their own way. So then they're not adopting a protocol. And very often these protocols are not in place, or even if they do get established, they just don't get followed. And so in terms of the solution, we don't want the management of the data to be a job in itself. And that happens very often. Many projects change hands, and very often due diligences will be done on the resource, for example, and they'll ask for a data room or the data. And so you want to be able to have confidence in your data, and that really is required by following protocols. Very often, if there's no protocol, you have no audit trails, for example, and the data remains dependent on the people rather than a system. So, we'll come to this, and then some of the features in Sable we have for managing the data. We obviously set up relationships between, if you've got an operating pit, for example, we ensure that the holes are related to that pit. They can't become detached. And that can apply to many data relationships. Samples must belong to a specific pit or a borehole, for example. And we have ways in the solution to move data around, always maintaining the integrity and the relationships. We have extensive functionality on validating the data and keeping it up to date. So if people are recording coordinates, for example, which is obviously very important to know where certain boreholes are drilled, we have validations to make sure somebody can't enter extra digits. That's a very simple validation. Other ways of capturing the data according to a standard, and I'll illustrate it, is using what we call lookups. So we have predefined lists for specific parameters, which obviously you can add to, but it prevents individual people from just ad hoc adding a new term, which may, for example, not be part of the standard. And obviously having a standard becomes ever more important when you have more than one site. So obviously, I'm sure many of your companies have multiple quarries or pits or operations, and you want to implement a standard across your whole company, for example. ETL, this little acronym on the right, ETL importing, that's a way where we govern the bringing in of data which you most certainly don't want manual tampering with, such as results from the laboratories. So we actually have configured ETL imports, which then have wizards for you to bring data in from the laboratory. We can obviously always set up live links to laboratories as well, where you have very high volumes of data. SAC-QC is where we check. So I know some of your operations, you do implement QC protocols, for example, in the limestone industry, where there are specific parameters and analytes which have to be within certain specs. So then you may be using QC samples in that environment. And we also have ways to set up restrictions to lookup lists. So if you were working in 2 different parts of the country and your classifications were slightly different, then we can limit those. So in a KZN operation, for example, we can have a certain number of terms in the same list versus one, for example, in the Northern Cape. So there's many ways that we can enforce and maintain a standard. And really coming to the end, we obviously there's often no data standards at all, and there's no accountability. And this can obviously have knock-on effects. So for example, if you are listed companies and you have competent persons, they can be held liable then, or it can put them at risk if you're not doing your work according to standards. So the standards we get in place have been proven over many years, and we're looking really to try and get the proven methodology of Sable into your industry sector. It's quite a new sector for us. We've spoken to Nico quite a lot about it already, and certain other people, and they are raising that there are issues around data integrity and consistency. So that's what we're looking to get to. And just in the bottom right there's a few other features within Sable. We have active validations, which is when at the point of capturing the data is almost going through a gate. And if it breaks that validation, you actually are unable to capture it into the database. We have Sable View graphics. I'll show you an example of that. And we have ways where we can use reference logs. So if you've got a type example in your operation and you want new employees, for example, to use that, we can obviously illustrate that and show that to them within the database as well. So I'll just switch now, and I'm just going to go through some of the features very quickly. So the first one, if you remember, was the SPD. So I'm just going to switch now. This is an example of a database I'm going to show you. And this dialog I'm showing you on the screen here. Sorry, I've just got the wrong one open there. Let me just open the right one here. My mistake. There we go. Okay, so this little dialog is basically where we define the data standard. So this is not the database itself, and I'm not going to go into detail on everything, but this particular screen you can see with all these blue icons, this would represent physical tables. So for example, if we had an open pit, for example, it might be located on a farm, and then the pit may be divided up into levels, obviously 1100 level, 1110, etc. And then subsequent maybe blocks, so where you have separate resources, it might be north, central and south. And you can see it's based on what we call a data tree. So each time a little icon is inset here, it's referring to a one-to-many relationship. So if you had one farm, on that farm you would have, one pit, for example, at this level, you would have multiple benches within that pit. And then per bench would divide it up into sections. And then ultimately you would get down, for example, to drill holes. And then on the right-hand side here, for this particular drill hole table, you would have a number of fields. So each row that you see here represents the definition of a column, or what you would think of as a column in an Excel spreadsheet. And you can see on the right, each column then has its specific data type, many of which we control by lookups, which means, that's what I said earlier, it's a list of predefined terms. That's the backbone really of how we maintain a standard. So if you were logging types of sand, you would have a lookup list of the specific types or specific type of aggregate. etc., etc. And you can think of many permutations there. Obviously, with boreholes, we would capture coordinates, for example. And then this second tab really is where we define all of the lookups. So we have them uniquely defined. They can have different lengths. And also part of the value here is everything is transparent. So you can see there's a lot of additional descriptive information, which you generally wouldn't have if you were working in a spreadsheet environment. You just have a column name and that's it. Whereas we try to expand on that, and we'll describe in detail exactly what's supposed to be stored in that particular field. And then we also have a significant amount of effort on validations. And you can see we have a master list. This is just some of them. And a very simple validation would be, for example, to have no gaps or overlaps when you're logging, for example, a profile in a pit. So it would force you to log from and to with a depth value. And we have the ability to return very user-friendly error messages, which we can configure to basically return whatever you want. So it's not like Microsoft Office where you get error 0009 and you haven't got a clue what it means. We actually give you user-friendly messages to come back. Right, then I'm going to sort of speed up a bit just with time. What you see here in this dialog is the actual data. So this is the example of data in a database. And on the left-hand side, you can see we have the data tree. So you can see the same blue icons here. And we have ways where we store the business unit. Data set is a very important level for us where we almost maintain what we would call the ownership of the data. So it might be somebody's name. And when you get to actually declaring resources, for example, for a limestone resource, you would actually have a branch, as we call it, called signed off. And then only the data in that branch you would use to back up a resource estimate, for example. That might apply to a clay resource for a brick making operation. And you can see we're extremely flexible in that we can deal obviously with surface or underground, might be exploration or production data. It doesn't matter. Let me just go back to this branch again. And we can see the one-to-many relationship. So in this case, this is diamond drilling and we have deflections. Okay, that would be Wits gold work, for example, but the principles are exactly the same. And in this particular table, we've got lithological logging. So we would have from and tos, a particular lithology. And if I just open here, that's an example of a lookup list. So you can see now how we would maintain a standard. Now, I know some people will try and do this sort of thing in Excel, but it is so easy to circumvent it in a spreadsheet environment. You can't put in strict security and restrict to lists without somebody easily being able to get behind it. And obviously then in Excel, you've got this one file, it's easy to email somebody. So the Sable solution will store all of this in a SQL database in the background. All right, and you can use SQL Express, which is Microsoft's free version. So you can actually keep everything in a very cost-effective manner. And you can see different fields have different lookups. Okay, so then it's not coming from one lookup. We're able to maintain the standard there. Right. As I mentioned, we do have, let me just get that one out of the way, the ability to bring in data from the outside. So we would have what we call ETLs from an import menu. And in this case, for example, we would bring in assays. So when you get results back from a laboratory, it could be any type of test. It could be aggregate tests or analysis of clay, for example. Then we give you a wizard which governs that data import into a very specific structure into the database. Okay. Right, let me just carry on. We're getting towards the end here. Another very simple thing is we have the ability to store bookmarks within the database. So as obviously your database grows, many operations may go for many, many years. So you can keep bookmarks to very quickly find specific parts of the database, just like you would in a conventional book. And you just go and jump to those straight away. In this case, this is just a view where we bring data from different tables together. Okay. Another example, as I mentioned earlier, is when you have reference logs. So if you wanted to actually get people used to your specific standard, then we can show, for example, an ideal example from one particular borehole. And then when people are capturing, they can see, okay, these units should be in this particular sequence, for example. That's another way of looking at it. So let me just jump back to the presentation here. I'm getting close to using up my, that's really just a list of what we looked at. So the benefits of data integrity, really, we can sum up in these three aspects at the bottom. We want consistency. And that's very important if you may have staff turnover, if you may have multiple operations, and you may be selling, you need to be selling the same products from different places to the same buyer, for example. Assuring the quality of the data, especially when that's where we would use lookups, for example, to maintain similar uses of terms, or QC protocols in analytical data, for example. And then thirdly, accountability. So because it's in a SQL Server database, we have a part of our solution is an audit manager. So every transaction on the database is recorded, just like we record this meeting. When somebody captures a new borehole or a new sample, that is recorded in a log in the background. So it removes, the ability for people to corrupt the data or to do underhanded things, or even if people accidentally do something wrong, at least then you can go back and find out, okay, who did it, what went wrong. So there's an accountability trail, all right, which we obviously manage through security as well. We can control very closely how different people can actually view and add data to different parts of the database. So that's a bit of a fairly rapid run through on it. But we would most certainly welcome interaction with any of you from ASPASA in whatever sector you are interested in or involved in, and welcome you to contact us. You can go and view some more information on Sable at this website here. Meshach is on the meeting. He's the team lead and product owner, and myself, I'm a senior consultant on the Sable product for DataMine. So you can reach us through those channels. And I'd like to thank you very much for your time and welcome any questions. And thank you, Theolan, for the opportunity.
Thank you, Alan. Very nice presentation. And I hope some of us will take you up on that offer. Are there any questions? Okay. Okay, Alan, thanks very much. If you could just share your details with Annika as well, so she can email it to everyone. Absolutely. So that, if you don't mind as well.
No, perfect. Thank you very much again.
Okay, thank you, Alan.
Thank you.
Okay, so next we have Teresa Arten from EXA. So from an EXA point of view, we've done some really good work over the last year. And yeah, Teresa, over to you.
Thank you very much, Dylan, and thanks for the invitation to present about professional registration. I have some slides. Well, they're not my slides, they're actually EXA slides, which I can share, but it's 45 slides, and I generally find what's a little bit easier, perhaps, is rather to chat to people about the questions that they may have. So I'll give a brief introduction, and then if people have questions, that would be really great if they could raise their hands or place it in the chat box. And then hopefully we can get a bit of a discussion going around how to register or how to go about the process, or any hesitancy that anyone has. Perhaps first, just to introduce myself. So I'm a lecturer at Northwest University in industrial engineering, but I also assist as a volunteer for EXA in the professional registration of industrial engineers. And I'm also on the council of SAI, the Southern African Institute for Industrial Engineering, and as my role in that, we also promote professional registration quite a bit. And as an industrial engineering community, what we're trying to do is encourage young graduates who have got their qualifications to consider registering, to try and create a level of accountability and responsibility in graduates to want to register, and to encourage people within the organizations to register. It's kind of one of those things that often people say is that there's no requirement for me to register. I don't see why I should have to register. And that may be true in a lot of organizations, and we're trying to shift that to a point where it is something that's valued and encouraged within organizations, that they value it in terms of promotion and salary, but that it's something people aspire to actually do we often also refer to chartered accountants. Chartered accountants always proud to write the exam and get their chartered accounting kind of certification, and we would really like the engineering profession to be similar. So my role in terms of EXA, so what EXA does is they have volunteers who are people who are previously or who have already professionally registered that they call in to assist with the application processes for anyone who wants to register. So as in my role through that, I have quite a lot of insight into the process of becoming candidates and applying, and I can explain to you how the process works and kind of what to look out for. We also mentor quite a few people who are putting together their documents. So I can also give you some input on kind of what to look out for and how much work it is, etc. So I don't know if there are any questions that anyone has. I don't really want to necessarily go through 45 boring slides. Warren?
Hi, Teresa. Yes, just from my side, at Lafarge, we do have a learning and development department. But I'd say for the past 1.5 years, we've been struggling to get hold of someone from EXA who can assist with EXA or the mentorship and commitment and undertaking for relevant graduates that we have in our operations. Do you perhaps have any contact details or know the correct people to speak to so that we can get something in place?
In terms of getting mentors?
Well, no, so I am a mentor, but just in terms of getting the commitment and undertaking completed. I know it's just a bit of paperwork, but it always is nice for the, for the company to say, look, we do have a commitment and undertaking with EXA for mentoring students.
Okay, all right. I can find out for you. I actually have no idea. I've never done that before. So we generally channel our mentors through the voluntary association. But I used to work for Bateman a long time in my history, and I remember they had one of those. So I'm gonna ask for your email address a bit later. But
Teresa, don't worry. I'll help Warren with that. I
you got it.
All right,
person that can help us.
Thank you. Thank you.
Teresa, maybe you can just take us through the slide in terms of what process the candidate would follow in terms of his application. Then we'll probably get some questions.
All right, good. As I said, these slides are EXA put these slides together, so I can share them with you. And maybe also to mention that EXA has all the documentation you need to apply is on the EXA website. The problem is there is so much information there that it's sometimes difficult to find everything. And that's also where it's really useful to have mentors because they can guide you in the right direction. These slides, I mean, the first, I kind of think 20 or 30 of them are really around like how EXA regulates the engineering profession, how they fit in terms of the council of the built environment, in terms of their body per se. And then there's the different categories of registration. So there's a professional engineer, a professional engineering technologist, and a professional certificate engineer or professional engineering technician. And these categories are determined by your qualification that you studied. So step one in terms of registering is you have to have an appropriate qualification that is recognized by EXA. So, most universities and universities of technology in South Africa will have got EXA accreditation for their qualifications that they give out. But there's also processes in place, for example, for people from other countries to get their qualifications recognized. There's like an extra step in that. But the baseline is you have to have an appropriate qualification. There actually is a separate process where if you have, many years of experience, you can put together kind of a portfolio of evidence to prove that you have equivalent experience to a qualification. But I mean, that is a kind of very long route, and you almost basically have to put a degree together based on your experience to go that route. So essentially, you have to have the qualification as your very first step. And then the next step is that you have to have appropriate experience. So you need at least 3 years of experience, and then you are eligible to apply. This is just gives a little bit of an expanded view of the different types of categories. And this is essentially what I was explaining now, which is kind of stage 1 is you need a qualification. Stage 2, you then have your training experience, and then you can professionally register. And then after that, there's 5 yearly renewal. That's when CPD points and things like that come into play. I'm not going to like read all of this, but I'll share it with you afterwards. You can also see here there are some differences in terms of education, in terms of the number of years. And this is also stems from the fact that there's been a lot of changes in qualifications, specifically in the universities of technology. So there have been some changes. So this table is quite useful. It gives you an indication of how many years was your education on paper, and then how many years of training and experience do you need. So for some, if you did the shorter qualification, you do need an extra year of training and experience. And there's also this table, which again, it's about the changes that have happened in the qualifications over the years. So you can maybe look up, use this slideshow to kind of just look up where your qualification sits, etc., to see how many years of experience you need. Then in terms of the actual, this slide is kind of semi-useful in that it gives you the codes. So ICSA uses these codes like R01, POL, PC to refer to all their documents. So you'll see once you start to actually apply, you'll start to fill in a whole bunch of these documents. And if you're applying, you'll be looking at that green block in the middle, the R03 PRO, the application and assessment process. And if you're a mentor and training graduates, then you can kind of look over to the right where you have the training and mentoring guide. And what's also really useful is the discipline-specific training guide, which takes the EXA outcomes and the elements of mentoring and training and then makes it a little bit more specific for the discipline, like industrial engineering or civil engineering or mining. So that's just in terms of the documents that they have. And then the key differences in terms of the 3 categories of registration, the outcomes are similar for all of them, but it's the level descriptor that explains kind of the level at which that person is interacting with problems, really. So for an engineer, it's about complex engineering problems. For an engineering technologist, broadly defined, and for an engineering technician, well-defined. And these are really important because when you get to submit your documentation, the panel will look at these things, like, are the problems that you're working on broadly defined problems? If they weren't, then that's gonna be an issue. You'll see it'll come up again and again in the outcomes that these words keep getting referred to. So that's a really good thing to keep in mind when you're getting your experience. So this mentions the employer registered under commitment and undertaking and saying that training programs need to be well developed, managed, and implemented. And that is absolutely great and really wonderful if you do work at an organization that has that, those formal training programs that guide you through. But it is, I think, really important to note that you don't have to have that. So there is no requirements to register that says you have to have been on a training program or that you have to have been developed under one of these. It's really nice that the company is committed and they do that. I'd say that's definitely first prize. But sometimes we get applicants who have had, they weren't working at an organization that had this in place, or they've kind of moved around a bit. And then they want to know, can they also apply? And yes, of course, you can. In fact, you don't even have to have been registered as a candidate. I think that the fees change in terms of how much they charge you, but you don't have to have been on a training program. What you have to have done is done at least 3 or 4 years of experience, and you have to have demonstrated that you can meet the outcomes. Like, that's essentially what you get evaluated on. So if you can have a formal program, it is really great. And there are documents that talk about the candidate's role, the supervisor's role, and then the mentor's role as well. Maybe that's also something to mention, is that we often have, specifically in industrial engineering, because we have industrial engineers that work in kind of companies that have never had an industrial engineer before, we often have people that don't have a supervisor who's an industrial engineer. They certainly sometimes don't even have an engineer, like a professionally registered person in their organization even, who can sign them off. And that again is not ideal, but it certainly shouldn't constrain you in terms of applying. So if you've been working in an organization and there isn't a professionally registered person at that organization, that is okay. The problem is that you need to have professionally registered people sign off on your application. And that's where the role of the mentor is really important. So those people normally will have to get mentors who are able to sign off their documents because they haven't worked under or with professionally registered people in the organization. So I think it would be good if we then jump to the 11 outcomes. So this is important. Like at the end of the day, this is what applications get evaluated against, is the 11 outcomes. They're divided into 5 sets, and the 11 outcomes are the same. It's the STEM that changes for the different categories, and the STEM is that thing around complex, broadly defined, and well-defined problems. We'll go through the outcomes quite quickly, but just to give you a sense of what they are, because they obviously are all outlined quite well in the extra documentation. And then I'll explain to you how the process works, because I think that's important. I think it's sometimes what people don't really understand. So these are the 11 outcomes. So you can see there in the first column, we can just read through the first one because it's easier that way. But the outcomes are things like, for example, define, investigate, and analyze, depending on your STEM, engineering problems, design or develop solutions to problems, comprehend and apply knowledge. Then there's things around management, so managing parts or all of engineering activities, communicating clearly with others. Then we have some around the impact of engineering activities, talking about social, cultural, and environmental effects, legal, safety in engineering. Then there's outcomes that talk about ethics, so it's about conducting engineering activities ethically, sound judgment, and then being responsible for making decisions. That's really important as well. And then showing that you have an understanding and willingness to undertake initial development activities sufficient to maintain and extend competence. That's kind of like a pre-CPD. So it kind of indicates that you know what that would involve, the whole CPD process. So these outcomes are what we measure an application against. We take these 11 outcomes and we measure it against these outcomes, and then we tick it off against those. Right. So this is also really important, is there's sometimes people are not sure whether the problem that they are working on classifies as complex or classifies as broadly defined. So again, in the extra documents, and it's quite useful here because it will include like the document name, that R02, etc. You can go and look that up on the extra website, and it will tell you, for example, for a complex activity, what would make it a complex activity. So there's kind of meets one or a few of these criteria. So it could be that it's got conflicting requirements, or that it involves a whole bunch of different multidisciplinary interaction, etc. So when it's really good if graduates have access to this kind of early on in their 3-year experience, so that they can start to look at what they're doing and say, does what I'm doing meet these criteria? And if it doesn't, then they can go to their supervisor and say, I need to get more exposure in such and such area. So that exists for all the different stems. And then this diagram, when you have it in PDF format, which is the only format I have it in, is quite messy because it doesn't annotate. But essentially what will happen is you will make a decision that you want to apply. You then have a whole bunch of documents that you need to complete, which are clearly stated on the extra website. It also helps if you have a mentor that will help you to put those documents together. But the documents include things like your training and experience, a summary of it, an engineering report, a detailed training and experience report, which outlines specifically related to those 11 outcomes, different work activities that you've done, and how that related to the 11 outcomes. So it's really good when people have applications that say, for example, that say, here is where I was developing sound judgment. Like, here is where I was exposed to something that involved making ethical decisions. So and really, I can't stress enough like how important it is to write a good set of documents. And the reason for that is when EXA receives your documents, an administrative person will kind of tick off that you've included everything, including 2 or 3 referee reports from professionally registered people, etc. And they will make sure all the documents are complete. And then those documents get sent to people like me, volunteers for EXA, who then evaluate these documents. And they normally send it to at least 3, sometimes 4 more people. And the people get to indicate, based on those reports, was competence indicated against each outcome. And if, and that's kind of, it's a bit difficult to see on my screen, I don't know if it's clearer for yours, but like on the left-hand side, it says there, 3 plus CI, that means 3 plus people said competence indicated. Then, the moderator signs it off and you go to the next step. In the red on the right, it says 2 plus CNI, competence not indicated. So if 2 people at that point decided your competence is not indicated from your documents, then you don't go to the next step. So going to the next step is completely based on the documents that you submit. Only people who pass that stage and go through moderation will then end up in what we call a professional review, where the person is invited to then do a presentation and ask questions to a panel. So it's not, doesn't like we often sometimes get people who write really sloppy reports, and perhaps they could have defended themselves in a presentation, but they don't even get that opportunity. And there's a kind of a variety of kind of appeals and things that happen within this process. But again, when you present when you do your interview and do your presentation, it's again people like me, volunteers who get called in as part of the panel to evaluate was the competence indicated against every single outcome. If at the documentation stage it's felt that you haven't met the outcomes, your application is usually put in abeyance. So they'll kind of give you a year. They'll say, these are the outcomes we're not happy with. Go back and spend another year getting some more experience in these areas, looking at this, and then you can kind of resubmit without going through that whole having to pay process again. So that's quite useful. Yeah. That's the process. And I think that's really it in terms of kind of an overview of how it works.
Teresa, just
maybe I'll
1 minute.
Stop the questions, yeah.
Yes, Nico.
Thanks, Theodolen, and thanks, Teresa, for your presentation again. I want to ask you something, because I think what you've explained here, and I've been thinking what you've been saying, and you must help me wrong, even Alex, the guys are asking questions. I think due to the change, the way we're doing things, in the old days, you would have, as a student or so forth, you would have an opportunity to go and sit with somebody, and he's your mentor, or he's all of those nice things to you. I think we've gone into a new way of doing it. And why I'm asking this is that I understand the companies are having problems in having the development of students take place. And not all companies have, as you've rightly said, your industrial engineers, because they're in the quarry industry. So what I'm trying to find out from you, we now as ASPASA, we've registered with EXA, and we need to now carry on and develop the thing better. Would it be a wise idea to say, in ASPASA, we set up a committee of whatever you want to call them, professional people, and we say, here's 5 or 6 professional people, or even 10 professional people. You're a student in Pofadder who's got a degree, who wants to become an engineer, and you can now contact ASPASA, and we connect you, and they do it over Teams or Zoom or whatever, and that person develops. That person might work for another company. That person might be you. That person might be anybody else. Because we're sitting with people that have got huge experience, and some of them are retiring, some of them are semi-retirement. And if we could ask them to become mentors and help the industry. I'm not talking about the companies. I think if I had to work for one of these big companies, I wouldn't know what to do either. So I'm trying to say that this. Now, I just want to tell you a little personal story. I phoned my son this morning, and he says he's busy with his master's degree, and he sits in New Zealand. He's a paramedic, comes out of a chopper and saves you, and he's doing a master's degree in aeroplane medicine. And I said, how many are you on the course? He said, no, we're 12. The lecturer sits in the UK, and we're all over the world. 12 of us are doing a master's degree. When we get into the aeroplane one day, we have to treat somebody. I said, what? He said, yeah. He says, we have to do what you said. We have to do a presentation. The people, or the other students and the lecturers comment on it. We have to answer the questions. So the electronic way of doing things, I think, has come to us. And I'm just asking if we as ASPASA, maybe with your help or Dolan's help, set up this committee, and we start developing people. Otherwise, how's the Oki going to be developed if you're sitting in Pofadder? I always use Pofadder as example. I don't know if you've been through there, but you don't mow your lawn there, you sweep the garden, and bugger all going on there. But I'm just thinking of, we talk about this, and I sit here and I want to register, and I'm not too sure where to do it, who am I going to get to help me, and then I say, bugger this, I'm not going to do it. So maybe with that in your mind, if you could give us advice as an industry, please, Teresa. Thanks.
Thanks, Nico. And absolutely, we have exactly the same problem in SAI. So, I mean, like, we actually have more than half our SAI council aren't registered either. So, I mean, yes, absolutely. So, I mean, a big thing SAI does, we do exactly that. So, we have people who sit in Pofadder who wants a mentor. They email our administrator, and then she puts together a CV of the person, and we send the CV out to kind of all our members who, have said they want to be mentors, and we say, this person is looking for a mentor, please can someone sign up? So we kind of have a matchmaking service that we run all the time to try and get everyone mentors. But we also kind of running informal workshops just like this to help people know what's understood. But I think more than that, what we're trying to do in the future actually is we want to, and I think it kind of really speaks to your situation, Nico. We have lots of people in your situation which have plenty experience. If they wrote up their report, they would get registered, right? But the point is, how do you make or help them to write up that report? Most people don't really feel like writing up a report. So we actually are thinking of running like a 2-day retreat where people have some homework to do beforehand, and then we sign them up. We're actually thinking of doing it in person. You have to come somewhere for 2 days. We take your phone away at the door kind of thing, and we then work through you for 2 days. Like, our guarantee is you arrive with the experience, we will let you leave the door with all your documentations complete and signed off. So yeah, because it really is a big thing to get over that, I don't even know, inertia of having to actually sit down and write the documents. Yeah. So it's a very good idea.
Yeah, thanks for that, Teresa. Yeah, I think if I just put my 2 cents word as well. So Teresa and myself, we sit on that virtual panel, so we've got experience obviously on the different routes, but alignment in terms of what's required. It is a daunting task of completing the documents, but I think a lot of the students, with some of the papers that I mark as well, they missed the boat in terms of what's actually required. So that alignment is required, and yeah, I also think that's a good idea. Further, EXA, if you do go through EXA as well, they can provide you mentors in your specific fields if there's a problem. But I think from our industry, I know Warren's online. Well, Teresa, that's more mechanical. We've got a few mechanical, we've got a few electrical in the industry. Civil, I know 2 that are in our industry, and Teresa now in the industrial, if required. But we can form something in the background. So obviously, I'll send some mails out in the background to a few colleagues, and then we'll see what we can do for ASPASA. Okay, Teresa, thank you very much, as always, and we really appreciate it from your end. And yeah, all the best. Is there any questions for Teresa, sorry, before she leaves? Okay. Okay, thank you, Teresa.
Thanks. Bye-bye.
Okay, bye-bye. Okay, moving along. So we now have Matthews Masagela, and he's going to be talking on blast vibration comparison between various drills and blast parameters. That sounds very interesting, Matthews. Take it away. Matthews, we can't hear you.
Okay.
I don't see that he's back online now.
Perfect.
Right. Yeah. Thank you, Nico. Let me just get my presentation and share with you. Okay. Can everyone see my presentation?
Yes, thank you.
Thanks, Matthew.
Just put it in present.
Can everyone see my Is it showing on your screen there?
Yes, all good, thanks.
All right. Oh, okay. Thanks, Teresa. Yeah, that was a nice presentation from EXA. I'm actually one of the graduates who are not yet registered because of the some delays and with miscommunication with our LND, learning development, and the EXA. So yeah, I think from this presentation, we'll get it right from now on. Okay. My name is Matthews Masarala. I'm a mining graduate. I've obtained my national diploma from University of Johannesburg in 2020, and then I came and joined Lafarge Peak Quarry in December 2020. So it's been a good 10 years of learning. Actually, the aggregates or quarry mining, previously in our course content in varsity, was not really shared broad and in details. So now we got an opportunity to actually learn more in details. Now, Lafarge Pequary is in Western Cape, Cape Town, around the River. We are mining. We produce aggregates as a hornfels stones, and in various sizes, different sizes, material, and the subbies as well. And then the rock processing at Lafarge Pequary begins at drill and blasting practice up to the crushers and screens utilizing load and hauling and conveyance. The mining industry uses million tons of explosives annually. You know that blasting is a major mechanism of rock fragmentation. That's where we get our product, and then we process it, we crush it, we mill it if needed, we crush screen up to various sizes. So now my topic about the blast variation comparison between various drill and blast parameters. My primary focus when I joined Lafarge was to focus mainly on the drill and blasting, load and hauling. But my graduate program covers all the aspects of the quarry. So now the blasting practices they cause vibration. We know when we blast, a lot of sound that happen. But now a lot of quarries that if you know that we are around the communities, mostly the communities are very near to the quarries. So we want to operate and not disturb the neighborhoods. So the vibration, we have what we call peak particle velocity, that's your PPV. We put the same seismographs that reads the ground vibrations when we're blasting, which is calculated in the millimeters per second. That's your vibration from the blast. Now, the overview of my presentation, the objective, why do you want to Why do I want to focus mainly on the vibration? Um, when we blast, the vibrations may cause harm or may cause some destruction to the neighborhoods, buildings, infrastructure around the quarries. But now, the health and safety at Lafarge Holcim is our core value, and we demonstrate health and safety in all what we do. So now we in compliance with the Mine Health and Safety Act 29 of 1996, or Chapter 4.7, where it says the employer must take the reasonable measures to ensure that when the blasting takes place and the ground vibrations, shock waves, and fly meters are limited to such an extent. So whatever the business that we do in the quarry or all the operations should not and should never disturb the neighborhoods or other outside areas. So we're making sure that every blast that takes place does not disturb the plant, infrastructure, nor the neighborhood. Now on this slide, I have a blast design here, the high PPV, which resulted in neighborhood complaints, some meetings with the DMR, surely even stop the operation so that we get to the point where we have like minimum vibrations that do not disturb the neighborhood. So now I've highlighted the main factors that actually contribute to the high vibration of your blast. That's your hole diameter, the parent end spacing, the charge per meter, and also the max charge per delay. So this is actually about the explosives that you pump in your holes, the diameter, the size of your holes that you drill on the benches. Uh, when we blast, we put up the seismographs around the neighborhoods where we pick up the seismo readings. Was it louder? Was it in the minimum readings? So now during that blast, it's actually the readings that I picked up from 2018 blast, one of the blasts that happened then. So if you can see now the vector sum, which is our ground vibration, the PPV, it was 19.68 millimeters per second, and the air pressure, which is your noise, it was 125 decibels, which is very disturbing and most likely get complaints. So imagine you're staying around the quarry every week or each and every 2 weeks. When you blast, your house moves, the vibrations. Surely one day it's gonna just destroy your house. Okay, now that's when I started to question now, what can we do? There's certain things that we can control. Well, you can't change the type of explosive or the explosive design. Surely it's how you design your blast to control the vibrations. Now on this next slide, I looked at the calculations together to how can we, if we minimize this, what's going to happen? If we increase there, what's going to happen? So how to minimize the ground vibration, the comparison between various drill and blast parameters, that's your bench depth, hole diameter, barren and spacing. So I compared the hole diameter for 102 millimeter and 115 millimeter. So if you can see my calculations there, the volumes and the total meters that you get per calculations. All right. So now from the diameter 102, you get your 1,750 total meters that has to be drilled. Whereas in 115, you get 1,330 meters to be drilled. But now in my conclusions that it's better to get to use 102. Well, you're gonna drill more holes, and which is more expensive, but then you get less vibrations. Okay, now my manager or any one of the mine can say no. Okay, come up with something that it's not less expensive. But now look into it. If for example the blast happens and then we have a complaints from the neighborhood. Surely, when the DMR is involved, there are going to be investigations. Surely, when they can have the processing of the plan. So imagine now when we stop the whole plan for the time being when they're doing investigation, how much are you going to lose? 3 weeks, 2 weeks? whatever the case may be. So now going down, that's your getting your powder factor, which is the how much volume, how much explosive that you use to break the 1 cube of a rock. All right. Moving right along. On my calculations going forward, the most contributing factor is the linear charge or mass per delay. There we're referring to the explosives that are pumped in the hole, in your hole. You're subtracting the stemming. So now the charge per meter, you're calculating the volume of your hole, and then which is your cylinder, and then you multiply by your density of explosives. Now going down, on my calculations, comparing the diameter 115 and the diameter 102. On the diameter 115, we got 13 kilograms per meter. That was our linear charge. That was our charge per meter. And on the diameter 102, we got 10 kg per meter, which is less. Meaning when we brought the whole bench, and you charge up the whole bench, you're gonna use less explosives. Then on this slide, I've went through and checked the recent blasts that we had, where the blasts are used the 102 diameter millimeter, which yield the low PPV. You can see from compared to the last blast design that yield a high PPV. He used 102 millimeter diameter, but then in space it was 3 meters by 3.5. The charge per meter was 9.8 kilograms. And you see the max charge per delay, that's your linear charge mass per delay. And on this next slide, that's your vibro readings picked up from that blast. You see there our PPV was 1.9 millimeters per second, which is very low. Our sound, our noise readings were 113.1 decibels. So yeah, that's perceptive, but it's not destructive. Some of the days when it happens, when we blast, you might not even notice anything. Now, yeah, just made my presentation very short. In conclusion, the aim is to keep the blasting activities, vibration, the noise within the 500 meters radius. So from where we blasting, that's actually on the picture, that's Lafarge Peak Quarry, in the aerial photo from the Google Earth. So we make sure whenever you blast, whatever that happens, if in case it happens as a fly rock or the vibration, must be contained within that 500 meters radius. Secondly, use a single initiation point or single hole detonation when you're using your timing. I haven't mastered this whole timing. I'm still learning around this timing, but a practical example, when I snap my single finger, it's audible but not enough. So now imagine if I snap out both of them, it's even louder. So now the single initiation point, we meaning that each and every hole goes out alone. Each and every hole goes out alone. Unlike using double initiation point where you're doubling some of the holes. So also that timing also contributes to your vibration of a blast. Lastly, reduce your hole diameter, the bench height, and button and spacing. Try to spill your benches, make it the minimum so that you won't have so much explosive that are pumped in your holes. All right. From my presentation, is there any question?
Yeah, I guess there's no questions. Matthews from us. Oh, there's Anthony's got a question.
Matthews, good morning. Yes. I noticed that your powder factor is the same on your 102 and 115 holes. Did you have a look at that by any chance? And then the other part of the question is, I don't know if I missed it in your presentation. If I did, apologies, but what is your timing that you're using on those blasts?
Okay. I don't know if I understood your question. You said the power factors were the same.
Yeah, there's very little change between your 102s and your 115s.
All right, yeah. The power factors for 115 it was 0.79, and then for 102 it was 0.74 kilograms per cubic meter. So yeah, there's a little change, but now a little change when you're now blasting the whole bench, maybe 100 meters of bench. It makes a huge difference. I mean, just a gram of explosive that is probably in a hole makes a huge difference. When it blasts out with the other holes, uh, that's when it makes a huge difference. So now with the timing, I haven't learned so much about setting up the timings. I'm still going through. I'm actually in the process of obtaining my blasting ticket. So yeah, it's still a learning journey for me in this drill and blasting. Okay.
Okay, and then sorry, one more, if I may, Fiolan. The difference between your 102 holes and your 115 holes on the fragmentation of the blast, did you have a look at that by any chance?
No, the fragmentation, I haven't looked at that much, because now my focus mainly was on the vibration results. So yeah, the fragmentation, maybe I can look into that. Obviously, it will depend on the material that you're looking for in your plan. Maybe you wanna have your ballast material at the end of the crushing. Probably your material has to be a little bit more coarse. And then if you wanna produce 127 dust, more of your 127 dust, it means you have to have your fine fragmentation. But yeah, I haven't looked into that as much.
Okay, thank you very much.
Thank you.
Thanks, Anthony, and well done, Matthews, again, for that presentation and answer to Anthony. Okay, just for the sake of time, all the best, Matthews. If we could move on. So we have now Alex Root from Interflon to give us a presentation or his company profile. Alex?
Hi, can everyone see me?
Yes, we can, Alex.
Yes. Okay, good morning, everyone. Good morning, ladies and gents. I know we're a little bit restricted with time here, so I'm going to try and keep it short and sweet. Warren approached me a few weeks ago just to talk about automatic lubrication, and we've been dealing with the Peak and Tigerberg quarries for just over a year now, looking at mounting automatic lubrication systems on a lot of the bearings on the conveying systems. So predominantly tail end, head end, snubs, and counterweights. So just to give you a little bit of background, I'm the branch owner for a company called Ambilube South Africa. So I own the branch in Cape Town and also the Eastern Cape, so the whole PE East London region. My second business is called Interflon. Now, both businesses sort of work quite closely together. Interflon is a specialist in lubrication. So high-end lubrication, greases, oils, cleaners, and we also do certain additives for heavy industry like yourselves and the industries that you guys are prominently involved with. So just to surmise everything quite quickly, I'm just going to talk about the automatic lubrication today, even though we do specialize in condition monitoring Lunetta pods for your oil sampling and oil analysis. So I thought I've only got a short slot. I'm not going to sit here for 40 minutes and go through all the different variables with you. Okie dokie. Right, let me just open that up quickly. Can everyone see the first slide?
Yes.
Yes. Okay. Perfect. Okay. So we're the importers of a product called Similube. So it's a Swiss company by the name of Simitech who actually manufacture all the automatic lubrication devices. They also do a very high spec range of induction heaters and fitting tool kits, bearing removers, to install bearings onto shafts as well. So we've got quite an extensive range of different products which we do supply the market in South Africa, or basically Southern Africa, everything sort of sub-Sahara. So so let me just start with the field servicing side of things. So when Warren approached me a year odd ago, and I came onto site and I did plant surveys on both the Peak and the Tygerberg quarries. So what happens is either myself or one of my technical advisors or field technicians will come to site and we'll do an on-site in-depth survey of all the equipment which we potentially going to mount these automatic lubricators to. So in this instance, like I said, we looked at all the conveyor bearings. We have other plants around the country and other quarrying manufacturers where we have mounted these points onto crushers. I know crushers is quite a critical piece of equipment, as well as screens. I do have a short video of about 30 seconds, which I'll show you guys in a minute, where we've got them mounted on the screens, where I know there's a lot of vibration, and it is a very difficult area to normally lubricate, and screens are, those screen bearings are bearings that require a lot of grease. Not only one, to grease the bearing, but two, to almost act for the grease to act as a labyrinth seal in order to prevent dust and muck and ingress actually getting into the bearings. Once the report is conducted, we'll look at the size of the bearings, and then from there we'll determine what size lubricator and what monthly settings the lubricators will actually be installed on. I know in the quarrying industry, a lot of the bearings are quite big, you know, ranging from anything from sort of 60, 80 mil all the way up to, you know, a meter and a half. So the right dosage of lubricant into the bearing is absolutely critical. You know, we've seen instances where even on places like electrical motors where over lubrication can be a lot more detrimental than under lubrication. So, you know, that's why the lube size is imperative. So this just gives you an example now, this next slide, of a lubrication report which all the maintenance managers and the foremen get on all the plants that we deal with around South Africa. So this just illustrates the lube number on the left. Then this in questions are actually the fans. So fan room, the application on the fan. So is it the drive end or the non-drive end bearing? Then we have installation dates. We've got refill due dates. And we've also got lubricant that's used. And then obviously the key columns which the engineers look at and the maintenance managers look at will be your levels. So this is a monthly report which our field technicians go out, check all the lubricators. And then if there's any feedback, it gets put on the report. The guys on site are made aware if there are any issues that need to be resolved immediately. So the nice thing with this reporting is it's also peace of mind. So, you know, we as Ambilube and Interflon, we don't just come in and do surveys and supply the lubricants and lubricators and leave them to your devices. one of the keys to my success over the years, being in this business for 23 years now, has been the follow-up and the maintenance of the lubricators. Because as everyone knows, nothing's infallible, things do fail. So, with the reporting system and the inspection system, which is done monthly, it makes it a lot more foolproof. So here is just a little diagram of the lubricator, and you can actually see with the cut lubricator all your different components in there. So you've got the cartridge at the top with your 2 little batteries. So once you've got a little timer at the top, which is a 1 to 12 month dial set setting. So once that's actually activated, what happens is the current goes through those 2 little batteries onto a fiber plate. And from there, dry cells producing a gas is formed. And it's a hydrogen gas, but it is completely intrinsically safe. So once the pressure builds up in the cartridge, it actually releases the gas and dispenses and pushes the piston down at a continuous rate. So the nice thing is the bearings are getting lubricated around the clock. And the beauty with the Similube is also it's not an injection of grease or oil into the bearing or onto your chain or slide or whatever the application may be. It's continuously pressurized. So an environment such as what you guys have got, where dust is very prominent and rife, you've got lubrication around the clock on there. So that is that's critically important. And I think that's also why we've seen so much success, especially in your types of industries all around the world. So you can see here there's a couple of pictures, different applications where we've got them installed. So you can see from your ball screws there, electric motors, your chains. So, it also doesn't matter which angle or which way the lubricator is installed. That we've had them on cams before where the lubricators are even rotating with the cam, and it won't affect the dry cell at all. So it'll still produce the right dosage of lubricant into the bearing on a daily basis. The temperature variances are also are pretty decent. So anything from -20 to plus 55 degrees C. We do have certain lubricators in some bakeries at Consol Glass, who are also very big clients of ours in South Africa, on a lot of their fans. And, some of the fans are running at around 60, 65, 70 degrees C. And what we do then is we just pipe the units a little bit further away. We've also got special protective covers to protect them both from heat, 1, and also 2 from rubble and, just getting knocked off. The lubricator is also completely water resistant. So we do have them on certain water treatment plants where they're actually submerged 1.5 meters, 2 meters underwater. So, the versatility of the products are quite exceptional. These are all the different sizes we have. So I know most of the quarries that we supply, we've got the 125 mil lubricator on those bearings. I know the crusher bearings, we did deal with the plant up in Saldanha for the last sort of 11 years before they closed that plant down. And we had the 250 mil lubricators on their crusher bearings with our Interflon LS2 grease, which is a grease which can take high impact loads, which is obviously required in that application. We've also got a new product which Simatech launched about 2 years ago called the Similube Impulse. So this is electromechanically driven. So what actually happens is the normal size lubricator, which you've just seen on the previous slides, will bar your multi-point. So your 15 to 250 mil slot straight into the back of this. So it's got this has got a single gear with a little drive motor. So what happens is the lubricator will dispense its normal amount of grease into the chamber, and then the second chamber actually pulses it out. So areas which you'll see in the little picture on the left, where it's bracketed and piped on that on that guard, it actually we've mounted that. It's running at about 5 meters, but yeah, with the 10 bar pressure, we can actually, depending on the lubricant inside the unit, we can push it even up to 8 or 9 meters. So also it just gives us a bit more versatility in terms of, you know, where we're installing it, the difficulty of actually mounting the unit near the bearings. I know when I did the survey with Warren last year, on some of those snub pulleys and counterweights, it was not very easy to get close to some of those bearings. And obviously, you know, if you are doing manual lubrication, I think that was also a big concern. The guys having to get up there, some areas erect scaffolding to actually go and just get up to grease the bearings every couple of weeks. So, you know, the nice thing with having the lubricators installed up there is it's just, you know, it's peace of mind in terms of your health and safety. You know, it ticks all those boxes as well. Not that this is really relevant here, but we also, the little 15 mil lubricator is something which Simatec launched about 3-4 years ago now. So we've got them on very small bearings. Actually, some electric motors, you know, if you've got small motors running at maybe 20 to 25 kilowatts, which only need a very small amount of grease, yeah, this potentially can be put on there. And again, it can be put on a 12-month setting. So all that lubricant is dispensed very, very small amounts. So you're looking at maybe 0.01 grams a day over a 12-month period, which is a minuscule amount. All the different success stories and different industries that we have from around the world. So you can see we supply, you know, most sectors. In South Africa, you know, we supply certain paper mills. You know, we do a lot with the food processing industries, your bakeries, your dairies, Coca-Cola, Unilever. You know, we do a lot of work with them. Vehicle manufacturers, so we supply Mercedes-Benz in East London. We do a lot of work with Toyota in Durban. So you know, all the sectors we tick, and obviously yourselves, you know, we deal with yourselves with AfriSam, with a few different types of quarrying and ready mix companies around SA. So these are the different regions which we supply. So we've pretty much covered most of SA. Again, as I said at the beginning of the presentation, I look after the Western and Eastern Cape. And then you've got JP, who looks after Rustenburg and Mpumalanga, also Botswana and Zambia. And then Jono looks after Durban, Pietermaritzburg, and the surrounding KZN area. And then Henrik Oosthuizen looks after the Gauteng region. So that's yeah, that's my presentation. I've tried to keep it as short and sweet as possible. I don't know if there are any questions at this stage.
Thanks, Alex, for your presentation and your company profile. Also, if you could just ask Anneke to send through your presentation so we can be shared with the team together with your contact.
Yeah, sure. No, well, thanks also for the opportunity to present to you all. I really appreciate it.
Thank you, Alex.
Thanks very much. Bye-bye.
Okay, time is not on our side, but we're right at the end. So I think maybe, you know, we can just take this opportunity and, you know, as I said in the beginning, just look at some engineering issues or updates from your areas. Are there any at the moment? Okay, so maybe let me start. I think the last time we had one of our engineers present on jaw crusher understructures. So I think over time, what I'm seeing as well, and I don't want to seem that it's an OEM issue, but you know, a lot of these understructures are for the jaw crushers, especially, becoming very challenging for some of the consultants to to design. And especially what we've picked up is some of the OEMs are not giving us active loads, from their areas for those crushers. So it makes it very difficult to design through the finance and put it on a finance element analysis to see if those designs are competent. So I am currently working with some of the our major OEMs to see if they can resolve that through R&D exercises, obviously at their cost, to try and get the different active loadings to the different types of material that we crush on various parts of our quarries. This year will obviously, it'll take our businesses forward because as we know, once those understructures start cracking, it's a catastrophic effect on the crushers itself. And no one wants to go to ask for CapEx to Exco. So yeah, so that is something that we are working. We've done some good work with the University of Pretoria. We shared that a bit in that meeting. But now it's obviously to get the OEMs aligned and ensuring that they comply to give us the right information required to design these underbases. So I think next year on our next session, maybe I'll introduce some of the engineering contracts. Warren's aware of that as well. I'll bring in 1 or 2 contracts to give you all some advice, that when you do get consultants in or even contractors, you can use some of these contracts that are readily available to ensure that what the scope of work is asked, it's materialized into the end product, and that from a legal point of view, you're covered over and above your standard terms and conditions. Okay, so are there any questions or any concerns from anyone else's side? Okay, so we'll leave it to the next meeting. Okay, then I think from my side, Nico, that's it. Just on a parting shot, have a safe holiday. And yeah, let's charge those batteries up back for next year. Thanks very much, everyone.
Thanks there, Nolan, and thanks for your best wishes. Yes, and mine is the same. Have a great break. I think we all need it. And yeah, we'll take a few new things on in the new year. And thanks for joining. Thank you very much. Bye.
Thank you. Bye-bye.
Thank you, everybody. Thank you. Goodbye.
Goodbye.